falling from the sky. Is it on?
Is that really how you would write your G's?
Stop, I just sang.
Alright, gravity is talking about how anything that has mass is attracted to anything else that has mass. Alright? So, what is gravity?
A force.
A force, okay. What causes the force of gravity?
Gravity. Mass. The mass.
Mass, okay, right.
Mass
So why is one thing that has mass attracted to something else that has mass?
Physics. Love.
Gravity.
Attraction.
Distortion of space-time, yes, okay. I was going to say that nobody really knows, and
Nobody.
you kind of get to the idea that it's distorting space-time. That's a great analogy for it, but it's not an exact reasoning as to why. Does that make sense? Magic.
Science tell us.
Fine.
Don't understand yet.
Nobody knows.
Oh, no.
Yeah.
Wait, nobody knows what?
Nobody knows why a chunk of mass
Why
is attracted to another chunk of mass. Now, there's this idea of warping space-time. So that, I mean, what is, like, you have the tarps and the things around them, right? But what's pulling down on the tarps, right? It gets this idea of Higgs bosons and all that cool stuff with that, and high-energy physics is just figuring that out. So if you guys want to learn about this, they could name something after Becca, even. Be
I think Dad
Becca
would
principle.
sound so much.
And she's like, can you put that law?
Yeah, Debke law.
Oh.
Now,
Debke theory. Debke theory.
what gravity says is that anything that has mass
Can you tell when people watch this? Yep. Oh, well, no, but I watched. Someday we're gonna like look back at these videos not for the information, but to see how stupid we sounded on them.
probably.
Well, it was.
All things with mass are attracted to everything else.
Third. All things with mass are attracted to everything. That makes no sense. All things with mass are attracted to everything else.
Oh, are attracted to everything else with mass. All right?
Sick of teaching physics for so long? Like you've done it all day and now you're doing it tonight too.
Absolutely not.
He's not allowed to say yes or
Career goals. Because you're so, like into his career. Like,
You're wearing a tie, not a bow tie.
Do you actually, like,
I know.
Well, he's not allowed to say he hates up there.
So, how do we figure out exactly how attracted two objects with matter are?
The equation.
Right. Now, Newton says that the thing...
More the numbers.
And the letters of the two.
Newton says that two objects are attracted by the terms of G, M1, M2 over R squared. Alright, now this R squared kind of throws a big monkey wrench in a lot of things, alright? Makes things very confusing because nothing becomes linear anymore.
Was this the butter gun?
Yeah, it's a butter gun, right?
I took
The
it.
butter gun video.
This thing.
Yeah.
I thought it was real, and someone told me it wasn't. It's not real, right?
Okay.
I still don't understand that.
It's a real invention that somebody does.
No. What's happening is, the butter gun says, if you have a piece of toast that's a distance R away, right? You shoot butter at it, you can butter one slice of toast. Now, if you double the radius, you don't double the number of pieces of toast that you can butter. You quadruple it. All right. The idea is that anytime something is dependent on a radius squared, it has to do with a sphere. All right. And so, as you get further and further away, the surface area of that sphere becomes greater and greater, exponentially greater. Right? If you double the radius, right, the force of gravity will become exponentially weaker. Yeah.
1A. What's G?
G is a constant.
Okay, I know what it is, but what's the value?
6.67 times 10 to the
Negative 11.
negative 11.
1B. Are we going to memorize that?
No,
No, it's on
it's
the
on your equation sheet.
backside.
1C.
Yeah.
Can we
6.67 times 10 to the negative 11. Alright, now, yeah, so tomorrow we're going to be analyzing that equation sheet, going over some practice problems. You know, all that stuff, then we'll know it inside and out. That'd be great.
How short are the periods tomorrow?
35?
Are they 32? Do you happen to know how long the dual credit test is?
It goes to like
7 to 9.
Okay.
like it's you go to Sunday. I mean, when you tell me what's on it, the scores on it said 9.
Guys, that's the physics review
sorry.
session.
Sorry.
Alright, so, Here's what I want to get at here, guys. If an object doubles the mass, what happens to the force of gravity? It goes up, right? By how much?
2.
Yeah, it doubles, right? Yeah. So Fg becomes 2x. Alright. What about if we double the radius now? Now first off, when you increase the distance between two objects, what happens to that force of gravity? Yeah, it becomes weaker. You know, they say absence makes the heart grow stronger. Fonder, whatever. I don't know. I don't believe in any of that crap. It's not true. What?
Is your love growing for her?
No, it's growing weaker because force of gravity, as you.
That is already recorded.
No, I meant that I miss her more. Is what I'm trying to say.
Gatone, if you guys
I
listen.
say-
I miss her more if you're like, run.
What I'm trying to get at here is as you increase the distance, the force of gravity goes down exponentially. Alright?
I feel very comfortable right
So
now.
if radius is doubled, I love my wife very much.
But less now because she's gone.
It's quarter. No. It's quarter. Alright? Does that make sense? The force of gravity is quarter.
Like, don't confuse me.
Quarter.
Don't say his name too many times. You might come.
I mean.
Awkward because Emma said it right.
Wait, that was really
Probably
funny.
gonna tell her this.
That was hilarious.
Alright.
That's so true.
Now, what about this? What if the density is doubled?
That does not matter.
Oh.
Or does it?
Well, isn't density? I don't know.
Alright, so we have planet A and planet B.
Density is.
Now, everyone take out your cheat sheet here. Everyone look at your cheat sheet.
That's better.
Are they supposed to be the same size circles?
Same size circles. Radius is the same, density gets doubled. So we say R1 is equal to R2. Alright? But, okay, where is density on here? Do you guys see it?
This is example
It's
one.
not D equals mv.
This is example one.
It's not P.
Density equals.
It's like the weird little like,
Yeah,
kind
row.
of like P, but it's not.
RHO.
Where is
Awkward
it?
little bell there.
Last number on the.
Lower left. Last equation in the bottom left corner. It's a row. Greek letter RHO, row.
To decide which P like
This is example 1.
The one's still on, yeah.
Alright, what if the density is doubled? Alright, I'm sorry, hang on. Density.
Yeah.
Alright, what happens now? So we talk about if you double the mass, if you double the radius, what if you double the density?
Double the mass.
What?
And you divide by 2 or what, half the.
Oh, they should be
Yeah.
Does it stay the same? So it doesn't.
You have to
never mind.
fourth the other one. I'm saying 8.
Yes, Matt, what do you think?
Double.
Doubled. Why do you think it's doubled?
Because the mass is also doubled then.
There you go. Take a look here, guys. Mass. The only thing that affects this, guys, density only is what's really it's coming to is it's affecting the mass, right? Now, it's unique in the fact that mass is equal to density times volume, right? And so, if you are trying to find the mass and the density doubles, but the volume is the same, well then the mass just doubles. Does that make sense? So assuming that the radius is the same, that means that the volume is the same. So if you double the density, you're simply doubling the mass, and therefore force of gravity is doubled. Alright?
So force of gravity is equal to 2x.
Yeah. So Fg is 2x. Now this gets really tricky when you start changing more than one thing. Alright? So let's say we, this is example number 2. What if we double the mass and double the radius? Or let's do mass is doubled.
Was this example 1?
Yeah.
And then radius is going to be tripled. What happens to our force of gravity? Oh, yes, Max.
2 9.
2 9.
Yeah.
2 9 is correct.
I think Laura needs some explaining there.
Oh, come on, be nice. Alright, take a look here. Fg is equal to gm1. Now, we've now doubled m2. And we've tripled the radius, but it's still squared, right? So if we want to compare this to the original Fg, so this is Fg2, this is Fg1, we now say, well, that's just gm1 m2 over r squared. And so now for Fg2, when we do all this junk, we end up saying, well, we pull out the 2, we pull out the 3, but we have the squared to pull out the 3. So that gets us 2 9 x. If you double the mass and triple the radius, alright, we're comparing Fg1 to Fg2. Becky, do you have a question?
Yeah, but
Okay. So now, let's do example 3.
how much room is it?
About the same as the last example. Now the density is doubled and the radius is tripled. Now, what happens to the force of gravity?